All right, we are factoring perfect squares. So these are special trinomials that factor in a special way. Let's look at the first one. You should always try to factor out a greatest common factor because that'll make everything smaller numbers. So it looks like there's a greatest common factor because your brain is like, oh, 4 goes into 12 and 12 and 9 have a 3 in common, but they actually don't have a greatest common factor. So you can't do that. Okay, so then the next step then is you're going to try to factor with two binomials. And we're going to use the trick factor by grouping. So if you remember the trick they taught, you take the first term, first coefficient, last term, multiply them together. So you get 36. And some people teach this with like this x. And then the middle term is 12. And so we need two numbers that multiply to make 36 and add to make 12. Well, that's 6 and 6. Right? So then we can break up the middle term into 6x and 6x. Okay, so we've got, I'm going to actually erase that so there's room here. We're basically going to break this up into 6x plus 6x. That's perfectly legal because that adds up to 12x. So we're just breaking it in half and rewrite the rest of the polynomial. And then we are going to factor by grouping. And on this side, what can go into 4x squared and 6x? So what can go into 4 and 6? 2. And then what can go into x squared and x? X. So I'm going to pull out the factor 2x, leaving 2x plus 3. And then on this side, what goes into 6 and 9? 3. So I'm going to pull out 3, and there was already a plus sign here. And so I have 2x plus 3. And notice I get exactly the same binomial here. So this is being multiplied with this, and this is being multiplied by this. So they have this factor in common. So we can factor out the 2x plus 3. And over here, I'm left with 2x plus 3. That's a confusing step for a lot of people, but you basically, since these are exactly the same, that's the outside factor, and then whatever's outside the parentheses is the other factor. So this trinomial factors like this. And you'll notice they look exactly the same, which means it can be written like that. And that's why it's called a perfect square trinomial. Now, here's a shortcut. If you had noticed that 4 is a perfect square and 9 is a perfect square, because 2 times 2 is 4, 3 times 3 is 9, that's usually a tip that this might be a perfect square trinomial, and you can skip all the factor by grouping and just kind of use some logic and say, oh, well, what's the square root of 4x squared? That's 2x. And what's the square root of 9? 3. And then say, I bet if I multiplied 2 of those together, I would get a 12 in the middle. And in fact, if you distribute that out, you will get a 12x in the middle. So you could have just gone straight to this step, and then this is 2x plus 3 squared. So that'd be your answer. All right, let's go to the next one. Let me erase here so I have more room. All right, so this trinomial is written backwards. We really like them in descending order if we're going to factor. So let's rewrite it. 49x squared minus 140x plus 100. That's a positive, positive. That's a negative, negative. That's a positive, positive. Let's fix that. 100. All right, is there a greatest common factor? Doesn't look like it. I mean, 7 goes into 49 and 7 goes into 140, but 7 does not go into 100. So, but 49 is a perfect square and 100 is a perfect square. So since this is a lesson on factoring perfect squares, I'm going to assume it is a perfect square. And so the square root of 49 is 7. The square root of x squared is x. The square root of 100 is 10. Except I need a negative 140 in the middle. So if I do that, that's going to leave a positive 140 in the middle. So these both need to be negative signs. Negative 10 times a negative 10 will make a positive 100, but a 7x times a negative 10 will make negative 70. A negative 10 times a 7 will make another negative 70. They'll add together to make negative 140. So this is factored like that. Okay, our last example here. 8x squared plus 112x plus 392. Well, the numbers are getting big, and when there's big numbers, it's probably done on purpose so that you will factor out a greatest common factor to make the number smaller. So let's do that. 2 will definitely go into 8, 112, and 392, but we want the greatest common factor. Looks like it's going to be 8. I'm guessing it's going to be 8, so let's try 8. We'll have x squared. 8 goes into 112. Aha, 14 times, so that works. And then 8 into 392. $49 times. All right, and so you're like, oh, I'm done. But look what's inside the parentheses. We have a trinomial, and it's a perfect square trinomial because x squared is a perfect square, 49 is a perfect square. So this is going to go x plus 7, x plus 7, right? Because the square root of x is x. Sorry, the square root of x squared is x. The square root of 49 is 7. And then these are exactly the same, and anytime you're multiplying two things together that are exactly the same, that's really something being squared. So those are all the examples you're going to run into factoring perfect square trinomials.